So welcome again, and you can see these are the picture of some resistance. You have, I think you have used this type of resistance, and you are familiar with this. So this section in the right hand side, this section is the resistance. Okay, and between these two, these are the inductance, or you may say this is the inductor. This is the resistor, and the nature is called the resistance. This is the inductor, and nature is called the inductance. This is the capacitor. It also has some legs, but it was broken. That's why you can see. This is the capacitor. Property or the nature, it is called the capacitance. So today we are talking about this in resistor. You can see there is a different type of resistor. So just remember why these resistor are different, because these two resistor are working. It may be it from this is showing very little, so you can't find the value exactly from this band. But remember, this is a, just assume this is just like a same resistor. Okay, these are the quite same in value. Slight difference is there, but you know what is why the construction is differ from each other. Anyone can say this? Assume these are the same value of this register are same, but why these are the differ?
different.
Yes, tell me, please.
सर डिफरेंट कलर्स रहता है इसलिए
नहीं डिफरेंट
प्रॉपर्टी सबकी डिफरेंट है, मेकिंग मेड जिससे सब ये अलग अलग टाइप के।
हाँ,
one is metal and maybe one is copper made.
एक्चुअली देखो डिफरेंट मटेरियल है, but why we use this different material? I am saying assume these are the same value. Just actually they are the same value, just quite change is there. Say these are the 200 ohm, this is the 230 ohm, this is also 200 ohm, and this is also uh, 1e, this is also say 200 ohm. Okay, but why we required this? Say this is all at the same value, 200 200 200, but why we required to produce this different material? Can you say what why this is a difference? What the reason? Application is difference, that's why we are making the difference resistance. But what is the difference application? Means which factor is differing, forced us to make it difference?
So resistivity.
Resistivity, please continue. Amar Kumar, please continue.
Resistivity of the both the materials are different, maybe different.
No sir, actually I am saying that these resistance are same. This is the 200 ohm, this is the 200 ohm, this is the 200 ohm, this is also 200 ohm. Just assume. But the construction, you can see the construction is totally different. This is the different, this is the different, and these two are the different. And I am not talking about these two. This is the totally another. This is variable, and this is another type of resistance. Look, in this resistance, there is the legs are same, but here the capacitor, the legs are not equal in length. So any idea, any concept, because there something is depicted, which factor just forced us to make it difference? Sir, answer is the what. You can see where the mouse is moving, here 40 watt is written, but this is the very small, that's why the wattage is not written over this small resistance, but in this big resistance there is the 40 watt is here. If this is not the 40 watt, say 400 watt, then same value 1e resistance, same value, but its construction will be much different because it will be greater. Okay, actually, where the application is there, application is varied due to the wattage. This is the 40 watt resistance. Say this is 200 ohm. This is also 200 ohm. And this medium size resistance is used for 2 watt. This is 2 watt resistance. This is 1 watt resistance. This is used for your electronics purpose. But whenever you go for your power application, a power system application or high power is going, just like producing this 40 watt and more watts, then you can't apply this resistance. You have to apply this type of resistance. So due to the wattage factor, we have to provide different of resistance. Maybe the value is same. This is also 200 ohm, this is 200 ohm, this is also 200 ohm, and this is also 200 ohm. I am just for convenience, just uh, assume this. And actually, if you measure this, the value is just like near about same. But the construction is differing due to the what. And this type of questions are coming in your face-to-face interview. Whenever PI type interview are coming, then they are asking this type of questions. This is the basic conceptual questions. Because you are applying whenever power sector, then high amount of heat are generating at the environment. That's why this is the high wattage capacity, and this is medium wattage power electronics based resistance is there, and this is only electronics based resistance where 1 watt is created, or it is circumstances is of 1 watt temperature. And you know, this is also called preset resistance, or it is called preset register. This is a variable resistor, but this is not a pot. I think you all know about potentiometer, or it is shortly called pot. But this is just like pot, but this is not exactly pot. This is called preset resistance. Okay, this is also variable. You know, this is the variable. If you put some screwdriver and move it, then the resistance will be varied. But why this is called preset? This is also applied in your electronic circuit or printed board circuit. But what happens? Just tell me why this is called preset. Anyone? Okay, because this is used in your electronic circuit. Say you need 73 ohm. Say you need 73 ohm. So you have to just set this value as a 73 or 75, whatever you record. So this is the 0 to 100 ohm resistance. So you have to apply 73. So in this case, 73 is preset, means you set this value 73. Then you just apply in your PCB for 73. Okay, and sometimes whenever you are going for the soldering, some 73 is just change, then again measure, just adjust 73, then it is going on. But it is not all time changeable. You don't do this. That's why this is called preset. We are setting this resistance as per our requirement, because if you made this absurd number of resistance, it is not possible, because resistance are at a certain value. We can adjust it, we can make it by arrangement, series or parallel circuit, but sometimes it is required some absurd value. This absurd value is given by this type of variable resistance. But we are applying this one or two times variation, because all time we don't do this. Okay, and this is, and look, this is generally nichrome wire, or some wire is there, metallic wire is there, and this is called carbon filament. These resistance are made of carbon filament resistance. Okay, I will show you the details construction, because I think you all know what is resistance, inductance, capacitance. But uh, we need some basic concept and very deep, clear concept of these elements. Okay, and these are made of filament, carbon filament, and this is the inductance, and this is actually called inductor. The property of inductor is inductance. So this is the inductor. This is look like this, just like capacitor, but this is not the capacitor. Okay, this is the inductor. Some coil and some core materials are there, and this is also ferrite core inductor. And this is the capacitor. Capacitor has so many varieties. Uh, Paper capacitor. This is silver mica capacitor, and there is also some capacitor is there, tantalum capacitors are there. All are not available to me, and in net you can get it. So this is a little bit about the concept and the construction of your resistance. Next class I will go for the details of resistance. Okay, and now the other part, here we are coming. Okay, so this is your resistance, and the unit of the resistance, you all know, this is the ohm. This is your unit. So what is the ohm? Now we have to know what is the ohm. We know the unit of resistance is ohm, but what is exactly, what is ohm? Definition. Ohm. So ohm is defined as the resistance offered by the material when a current of 1 ampere flows between two terminal with 1 volt potential difference. 1 volt that is applied across it. This is the ohm, and you all know what is the Ohm's law. Just remember, So if the all physical phenomena remain unchanged, then the current through the conductor, all physical phenomena means temperature, length, etc., all are the constant, then the current through a conductor between 2 points, through a conductor between the 2 points is directly proportional to the voltage across the 2 points. So it is saying current is proportional to V if all physical phenomena or physical conditions are remain unchanged, means length, diameter, temperature, etc. So I equal to K into VR. K is the constant, you all know, and you know I equal to V by R. Okay, or we can say this V is the R into dq dt. I equal, okay, dq dt. You have just seen what is I, dq dt, and this I, this I is V by R, V by R or small r, whatever you can write. Okay, and this is called GV. This is G and V. G is, look, here is I equal to V by R. So we can write I equal to 1 by R into V. This 1 by R, this 1 by R is called this G. Okay, this is called conductance. Conductance. Okay, this is just 1 by R, opposite to the R, and unit of this conductor is just opposite to the ohm. It is called mho. Ohm and opposite is mho. Just remember these things. And now just remember another thing. Those who are from electronics department, they know well the difference between conductor, semiconductor, and inductor. This is conductor, this is semiconductor, and this is insulator. Okay, so for this conductor insulator difference with respect to resistivity, it is lying between 10 to the power minus 9 to 10 to the power minus 4 ohm. Okay, for this semiconductor, this resistivity lying between 10 to the power minus 3 to 10 to the power plus 3. Okay, ohm per meter. This is ohm per meter. Okay, and for the insulator, 10 to the power plus 4 to 10 to the power plus 17. Okay, lying between this ohm per meter. You can see this. What is the difference for conductor? Minus 9 to minus 4. Okay, within this range, the resistivity is lying. For the semiconductor, minus 3 to plus 3. And for the insulator, this is 10 to the power 4 to 10 to the power 17. Resistivity is so high, that is positive 10 to the power positive 4 to 10 to the power positive 17. And the temperature coefficient, next point, which is the difference. Sorry, temperature coefficient, not temperature difference. This is for the conductor not constant. This is temperature coefficient, this is negative, and this is varying also. And in this case, negative but high value. Okay. This is all about your resistance. If you have any question, then you may ask me, then we'll go for the inductance.
Sir, temperature coefficient.
टेम्परेचर कोफिशिएंट देखो, कंडक्टर में क्या होता है, जब टेम्परेचर हाई होगा, whenever temperature is going to high, then resistance is also going to high. But in the semiconductor, whenever temperature is going to high, then its resistance going to down, means it's try to conduct, just like your sphere. Just remember, are you from EC department or electrical department?
Sir, EC department.
Okay, you know well what is the sphere. Sphere, okay. So sphere can be fired or sphere can be turned on in the four way. So one of this is the heating. If you, because you know this is, if there is a anode cathode is there, anode cathode is there. So this terminal is called this gate. So whenever you put some voltage, then and then sphere will be turned on. Okay, this phenomenon you all know, and you also know there is a four way to turn on this sphere. Okay, the one of this is the temperature. If you don't put any voltage over this gate, just make it free. But if you going to rise your temperature, just temperature is high, first this is 28 degree centigrade, then 30, then 40. After some temperature, after some certain temperature, the sphere will getting turned on, because whenever you increase your temperature, then it will showing your conductance property. So this is the temperature coefficient. Okay. So whenever you increase your temperature for your conductor, for your metal, its resistance will high. You all know. Whenever temperature is high, then resistance also going to high. Okay, just like its application is heater, your normal nichrome which is applied in your heater, normal heater, room heater, normal cooking heater. Whenever temperature is rise, then you can see there is some, it will be heated and temperature also rise. Your bulb, incandescence bulb, okay, which is glowing. But in your semiconductor, because its resistance will high, going to high, increasing, and in your semiconductor, whenever you increase your temperature, then resistance will going to the downward. So this is the negative relation, is just inversely proportional. Temperature is going to high, resistance will going to low, down. So this is called the negative temperature coefficient, and this is called the positive temperature coefficient. Okay, because you remember this thing, whenever SCR is turned on, there is a four way to turn on this resistance. One is gate pulse, another is laser application in this gate, another is temperature rise, and another is voltage increment, means high potential difference. High potential difference, then this will be damaged. Okay, maximum time it will get damaged if you apply high potential difference within anode to cathode. But there is one of this is there, the temperature turn on method. If you increment the temperature, then it will turn on. So temperature rise means it loses its resistance. Whenever it loses its resistance, then after some time there is a no resistance. Zero resistance means this is the conductor. It will flow all current through this. Okay, so this is the negative temperature coefficient. So if you get some ratio, then you can get some coefficient. This coefficient is called negative temperature coefficient. But in this case, conductor are always positive temperature coefficient. Whenever temperature is rise, resistance also rise. Okay. So we are going for the inductor. You all are familiar with this material, this components. This is called inductor. Look, in electrical branches, you can see three components, basic components are there. One is resistance, another is inductance, another is capacitance. So these elements are called resistor, which has the resistance, and which has the property of inductance. This is called the inductor, and which components have the property of capacitance. This is called the capacitor. So next topic is our inductor, and the property of the inductor is called inductance. Okay, so how the inductance is created? You remember, whenever a current is flowing through a conductor, this is a conductor. Whenever a current is flowing, its surrounding area, a magnetic field is created. A magnetic field is created. You all know this because you have read this. But if you want to see this practically, just remember Ampere swimming rules. Ampere swimming rules. You have seen, if a current is flowing, it may be AC or it may be DC. But in your 12th class or the 10th class, you have dealt with the DC current maximum 99% times. Okay, so whatever may be AC or DC, there is a current flow. Then if you put some magnetic needle, this is magnetic needle, it is available in your compass. Okay, this magnetic needle, say this is the north pole, this is the north pole, this is the south pole. Then if you put this magnetic needle, and if there is a current flow surrounding this wire, then this magnetic needle will be deflected. This magnetic needle will be deflected. Why this magnetic needle will deflected? Because whenever current is flowing through this conductor, it creates some magnetic field surrounding this, and only a magnet can react with the another magnetic field. Magnet can react means repel or react with the another magnetic field. Okay, because there is no, because this is a copper material, this material is a copper or aluminum, this is not a ferromagnetic material. So this magnet never attract or repel this material. But why this is deflecting? Because a current is flowing this copper wire or the aluminum wire, And that's why a magnetic field is created. A magnetic field is created with this surrounding wire, and this magnetic field is reacted with this magnetic field of the copper. You know, if there is a magnetic bar, north pole and south pole is there. From the north pole to the south pole, there is a force of line is created. This is not new to you because you have already studied this. And this field are reacted with each other. So it has only the movement, it can move because this is mounted on this magnetic needle, so it will be only deflected. So from this phenomenon you can realize whenever current is flowing through a conductor, this conductor may be made of copper or made of aluminum, whatever may be, but this is a conductor. It's create a magnetic field. It create a magnetic field surrounding this area, and this is just like a cross sectional area of this magnetic field. So whenever one wire created this magnetic field, say I am drawing this coil. This is a coil, one round or one turn. Those who are from electrical department, they know this is called a turn in your transformer, motor, etc. coil. Say this is a coil, this is a coil. In this coil, 1, 2, 3, or maybe number of uh, wire are just make it as a coil. So whenever a current is flowing, through this coil, so current is coming from here and going to here. So I am selecting a particular area, this cross-sectional area. What happens over there? You know, whenever if this line, this conductor carrying a current, each every area, it's creating a magnetic field. So I am selecting this particular area. So what happens? It will also create a magnetic field. It's one force of line. This is one force of line. So 1, 2, 3, each cross section area there, it is creating a magnetic force of line. So you know it has the direction. This is the north pole to the south pole. North pole, it is coming from the north pole and entering to the south pole. So if you, this is just like a one vector sum. If you take this, here, just one position, just like this, you are take this, say this, take this, say this, take this. So you can see here is small force of line is there. If you take this also just like a tangent, okay. So one force line is created. So if you know the vector sum, if there is same direction is there, it will be added in a one direction. So each cross sectional area create one force line of force. Okay. So, or you can say this is force line. So every cross sectional area create one of so many line of force. Okay, so this magnetic line is created. This is called field. Which field? This is a magnetic field. So whenever in a coil, if it is a coil, if there is a flow of current is occurred, it may be AC or DC, a magnetic field is created. I think you can understand why a magnetic field is creating from the very basic things, one by one, step by step. So it has some direction. This arrowhead is north, this tailhead is south. So whenever a coil is carrying some, say this is a coil, carrying some current, its actually core region is create a magnetic field. It look like or similarly just like a magnetic bar. This is a north side, this is the south side, because from north side it is going to out and south this is entering. So here from north it is coming out and south it is entering. Okay, in this way it is creating a magnetic line. Up to this, is that clear to all of you? Okay, whenever a magnetic field created by this coil, whenever current is flowing through this coil, a magnetic field is created. So magnetic field means it is the energy, but this energy coming from where? It is coming from this flow of current. If you cut this flow of current, it will dissolve at that moment or within few seconds, because storage factor is working there. So it is only dependent on this flow of current. Okay, so this energy is stored in this inductor. That's why inductor is called a storing element. But inductor stores its energy in the form of magnetic field. Inductor stores its energy in the form of magnetic field. So whenever it is storing, after this storage is over, whenever it will get to discharge, it will discharge in the form of current. Okay, so this is the characters of the inductor. But capacitor store its energy in the form of voltage. Okay, so inductor working only when change of current condition is occurred. Remember, change of current. If current is constant at the time 1, this is 1 ampere. I am saying at the time t1 this is 1 ampere, at the t2 this is 1 ampere, at the t3 it is 1 ampere. So no inductance property are showing. This is just behaves like a resistance. But if at the t1 it is 1 ampere, at the t2 second it is 1.2 ampere, at the t3 second it is 1.5 ampere, change of current is occurred, then it's also a storage capacity is appeared in this inductor. So whenever change of current is occurred, then only inductance property will applied over this coil, and after some time it will store up to its capacity, then it will try to discharge. Okay, so this is the property of inductor and basic concept. And guys, if you have any question you may ask me. Only 1 minute is less than 1 minute is left. So guys, have you any question up to this? Okay. Okay guys, thank you. I'm going to end this session.
Thank you, sir.
You are welcome.
Thank you, sir.
Thank you, sir.
You are welcome.
Thank you, sir.
Have a
Thank you,
nice-
sir.